Hello, welcome to Unit 5 review. Learning objectives are all our targets from the unit. I can divide multi-digit whole numbers by 1 and 2-digit whole numbers in cases with and without remainders. I can interpret the remainder of a whole number division problem in a way that makes sense in the context of the problem. I can describe the shift patterns that occur when a number is divided by powers of 10 that are expressed with and without exponents. I can divide whole numbers and decimals by decimals to the hundredths. I can solve real-world problems. I'm going to just do one page at a time so students can find the problems that they need help with easily. So the first page, page 233. Problem 1. Select the expression that involves a shift of digits to the right 2 places. Mark all that apply. So we're dividing by multiples of 10. I know when I divide by 1,000, my digits are shifting to the right because it is making it less. But when I divide by 1,000, I'm shifting 4 places to the right because they're saying my digits. 30 divided by 10 to the second power. So 10 to the second power is 100. The 2 tells me I'm shifting my digits 2 places to the right. So let me get my pen. And B is a shift of 2 places to the right. 2 divided by 10 to the third. 10 to the third is 1,000. The 3 tells me the 2 would be shifting 3 places. It would be 2 thousandths. D, 7 divided by 10. When I divide by 10, there's 1 0. So I know I'm shifting 1 place value. 10, every place value is 1/10. 400 divided by 10 to the first. 10 to the first is the same as 10. 1 tells me I'm shifting only 1 place. That would only be 40. 8 divided by 100. 100 has 2 zeros. That means I'm doing 10 multiplied by 10 or 2 place values. So F would be the other one. That was kind of a tricky question. It didn't say there would be more than one answer, did it? Select the expression. It should say expressions. Number 2, classify each quotient as being equal to 52, equal to 5 2/10, or equal to 52 hundredths. Write the letter of the quotient in the correct box. Again, it's dividing by multiples of 10. So, dividing by 10 to the second power, the 2 means 2 place values, so I'm going to shift my digits 1, 2 to the right, or my decimal to the left. So A is going to go here, 52 hundredths. Dividing by 10 to the first means to shift my digits once to the right, or my decimal once to the left. So B gives me 5 2/10. C, 52 divided by 10 to, or 520 divided by 10 to the first. The 1 means 1 place. I'm shifting 1 place. My decimal would be here. It would be 52. C. D, 520 divided by 10 to the second. The 2 in the exponent 2 means 2 places. 1, 2. Whoops. Don't ask me why it did that on me. So sorry. I believe it was here. So D goes here. I probably should put a comma between it, but we're not going to waste time at it. Dividing by 10 to the third, the 3 means I'm shifting each digit 3 places to the right, 1 place to the right, 2 places to the right. 3 is 520 thousandths, which is equivalent to 52 hundredths. So E goes here. F, dividing again by 10 to the third, 3 places, 1, 2, 3, puts my decimal where their comma was, 5 2/10. So F would go here. And of course, if you still don't understand any of these, please email your math teacher to go over it with you, or even me. I'll be happy to do it with you too. Number 3, explain why 3 6/10 divided by 400 has the same answer as 360 divided by 4. And that is because they are equivalent division problems, division expressions. When I multiply my divisor by 100, that shifts it 1, 2, or multiply it by 100, sorry. That shifts it to the left, but I have to multiply my divisor by 100. Multiply by 10, 100. Makes it there. So in words, I put it this way. When the expressions are written as fractions, 3 6/10 over 400 and 364ths, these fractions are equivalent fractions because 3 6/10 over 400, when I multiply it by 1 in the form of the fraction 100 over 100, 3 6/10 multiplied by 100 is 360. 400 multiplied by 100 is 4. So that proves that these two are equivalent fractions. And since the fractions are equivalent, so are the division expressions. Number 4. Why does dividing 5 by a decimal less than 1 give a quotient greater than 5? To me, in explaining this one, I would use a diagram first. If I have 5, and that's not what I want to keep doing, so let's copy 2, 3, 4, 5. So if I had 5 and I divide them by a decimal less than 5, well, let's divide them just by 5/10. So if I think of 5 divided by 5/10, since 5/10 is less than 1, I'm dividing each of these into groups less than 1. How many 5/10 are in 5? Well, 5/10 and 5/10 make 1. 5/10 and 5/10 make 2. 5/10 and 5/10 make 3. And I see I'm running out of space, aren't I? So I got to go a little smaller. 5/10. Oh, let's just do it this way. If that's 5, 1, 2, 3, 4 lines. If that's 5, there would be 2 5/10 in that one, 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 and 2 5/10 in that one. There would be 10 5/10 in there. And that means there would be oh, I don't have the reds for some reason. So, but there would be 10. I'll go in and put in the reds in a second. There would be, and that's going to make a mess there, but that's okay, because we know what we're doing. There would be 2, 3, 4, 5, 2, 4, 6, 8, 2, 4, 6, 8, 10 in that one. Oh, I see what I'm doing wrong. There would be 2, 4, 6, 8, 10 in that one, 2, 4, 6. Nope, now I'm doing it wrong the other way. Sorry about that, guys. 2, 4, 6, 8. No, I'm still doing it wrong. 10 in that one. 2, 4, 6, 8, 10 in that one. So 10, 20, 30, 40, there would be a total of 50 5/10ths in each one. In words, I would say, you are dividing 5 into equal parts smaller than one whole, so there will be more than 5 parts, because I'm dividing the 5 into parts smaller than one whole. See, each part is smaller than one whole, that I have more than 5 total parts. Number 5, a farmer ships 4 times as many oranges as tangerines. The farmer ships 8,260 oranges. How many tangerines does he ship? Write an equation, then solve. All right. Before I would write an equation, I would use a diagram. My diagram would look probably similar to this. I know he has more oranges than tangerines, so I draw it to show that my tangerines are about 1/4 the size of my oranges. Then it says I have 8,260 oranges. And since tangerines, how many are tangerines? Well, there's 4 groups of tangerines in there. Now I get it. So first, I could use a situation equation. The farmer ships 4 times as many oranges as tangerines. So 4 times the tangerines would equal 8,260. Well, because 4 times the tangerines equals 8,260, now I would change that to a solution equation of that is the same as taking the 8,260 and dividing it by 4 to figure out how much are in one set of tangerines. And when I do that, I get 2,065 tangerines. Is that reasonable? Well, that's about 2,000, 2,000, 4,000, 6,000, 8,000. I have about 8,000 oranges. So yeah, 4 times 2,065 is going to be about 8,260. All right. If you have questions, any further problems, watch the next video. I'm going to do these each one page at a time.